What is up, everybody? It's 2.4 Systems of Linear Equations. We have, this is the third video, I think, of the In-Grid Math 3 series. It's 2.4 because I covered two series. Two sections in one series, So this is a Systems of Linear Equations. It's called a system. I think it's also called like simultaneous linear equations in the UK and Australia. It's also called simultaneous equations. So, and it makes sense because there's more than one equation. So in this graph right here, the thing that's special about this is that there's two lines and they intersect at one point. This point is the solution to the system, or the simultaneous amount of linear equations. And in this picture right here, picture I got off the internet, there are three planes. So one plane right there, right, it's a little hard to see, one plane right there, right, and then one plane right there. Okay. And you could see that they cross at one particular point, and that point is right there. So everything comes into that point. This comes into that point, that comes into that point, that comes into that point, that comes into that point. Everything comes into this one point. So these three planes have a system of have one solution. So there's a system, consecutive equation. So how do you solve systems of linear equations? So I'm going to use the line tool. To solve the equations, you can do it three ways. You can do it graphing, right? You can do it by substitution, or you can do it by elimination. But we're gonna do that later. First of all, by graphing. So for this graph, we got y equals 3x plus 5. We should know a graph already. So that's 5, right? And then we can do 1 over to the right and 3 up because that's a linear equation. Let's go down a little bit. Let's do. There you go. Okay, and then we can kind of extend it up. There you go. That's the line. And then for this line, we can plug y equals 0. So then we know y equals 0, and we can solve for x. So y equals 0. That's a 0, and we got minus 3x equals 2. So x is equal to negative 2/3. And we can do 0, negative 2/3, which is about right here. Then we can plug 0 in for x, and we get y is equal to, y is just equal to 1. So the line's like that. Therefore, now we can plot that line as well. From here to there. There you go. And we can extend it. Boom, that's our solution right there. It looks like 2.5 negative 2. That's our solution. So 2.5 for, no, negative 2.5, negative 2. Negative 2.5 for the x, negative 2 for the y. Next, we got solve by substitution. Now, the substitution means you have to substitute it into the equation, assuming that they're all equal, assuming that y is equal to x plus minus 6, that 3y is equal to 3x minus 6, because y is equal to x minus 6. So it's kind of obvious that 2x minus 3x. No, that's not how you do it. 3x minus 6 equals 8. So I can solve this equation, and I can simplify the equation by doing the distributive property. I'll get 3x plus 18 equals 8, and then end up with minus x equals minus 10, therefore x is equal to 10. Now I can put the 10 back into this equation. Because they're both equal, it doesn't really matter which equation you use, you're still going to get the same amount. So 10 minus 6, so y equals 10 minus 6, therefore y equals 4, therefore the solution set is 10, comma 4. That's the answer. Now solve using both ways. So first of all, y minus x equals 0. So I can just add x to both sides. We're going to do it by substitution first. Now we have y equals x. So y equals x, I can put the x into the y right here. So I can have y equals 2y, y plus 2y equals 3. So 3y equals 3. Therefore y is equal to 1. Since the y is equal to 1, we can put the 1 in here. We'll get x plus 2 equals 3. X plus 2 times 1 equals 3. So then x is also equal to 1. So the solution is 1, comma 1. Now we graph it. If we graph it, it'll be it should be the same as well. So first of all, y equals x. We're going to graph our y equals x. That's just going to be this line right here. And then we're going to graph our so we're going to subtract x from both sides. Subtract x from both sides. And then divide by 2, so we'll have y equals negative x over 2 minus 3 over 2. So, no, wait, is it minus? No, it's positive, plus 3 over 2. Okay. And then we can graph that. So 3 over 2 is right here. No, 3 over 2 is right here. And then we graph every 1 to the right. We go, now every 2 to the right, we go 1 down. So 2 to the right, 1 down, so we'll hit right there about, so then this will be the line. No, that's the wrong line. This will be the line. There you go. And then we can extend it. And there you go. The graphing solution is right here. And it is 1, 1. Okay, next method, we have solve by elimination. Now elimination means you can add, subtract, or make any function, make any equation double or half or by any scale in order to solve the equation. So in this solution, we got 3x plus 4y plus equals 8, 3x minus 2y equals negative 4. Which one do we want to use? Well, we want to eliminate one of the variables, so it's easier for us to solve the equation. So let's eliminate the x's since they're the most simple. So now we have minus this whole equation. 3x minus 3x is just 0, so we're not going to put anything. 4y minus 2y, so that's plus 2y is 6y. And then 8 minus 4 is 8 plus 4, which is 12. So then the y equals 2. Y equals 2. Now we can put the y back in here. We'll get 8 equals 8 plus 3x. 3x equals plus 8 equals 8. So then we'll get 3x equals to 0. So x equals to 0. So the solution is 0, comma 2. Now this next equation. So we want these to be equal to each other. We want one of the variables to be equal to each other. We can subtract or add just like this really easily. However, none of them are. So we are forced to use a scale in order to make one of them equal, in order to make one of the variables, at least one of them, equal to each other. So we can solve. Now x and 2x, we have a scale of 2. So we multiply by 2 to get 2x. So then we can multiply this whole thing by 2. Now we have 2x minus 4y is equal to 12. However, there's a discrepancy here. How can 2x minus 4y equals to 12 if 2x minus 4y is already equal to 22? It can't. There's no possible way. 12 cannot equal 22. 12 cannot equal to 22. So this equation has no solution. No solution. The 2x minus 4y equal to 12 it cannot equal to 22 because they are parallel. So we have all of the points that are equal to 12 on one line, and we have all of the points that are equal to 22 on the other line, and they don't intersect each other because they're the same line. Therefore, there's no solution. Okay, next. We have solved using any method now. So you can solve using any of your methods. 3x plus 2y plus z equals 1. X minus 2y plus 2z is equal to 4. 2x plus 4y plus 3z is equal to 9. Now the easy way to solve these two equations would be to use substitution. The easy way to solve these equations would be to use matrices, but we're going to use substitution to solve this equation. So we're gonna isolate z. We'll have z equals 1 minus 3x minus 2y. Now we're gonna put z in the second equation. So z x minus 2y plus 2 times 1 minus 3x minus 2y is equal to 4. And then we can open the equation. We'll have minus 6x minus 4y is equal to 4. And then x minus 6x is minus 5x. Minus 2y minus 4y is minus 6y. Plus 2 is equal to 4. Subtract 4, subtract 2 on both sides. Okay, anyways, subtract 2 from both sides, it's gonna get really messy really quickly. Minus 5x minus 6y is equal to 2. I think that's still visible. Yes, okay. And then we want to isolate one of the variables, so we're gonna isolate y in this case. Let's move this to a different spot. There you go. So in order to isolate y, you do y is equal to add 5x, 2 plus 5x, and then divide by negative 6, so minus 6, and that's our y isolate. So then now we can put this back into the z, which we already had. So now we have z equals 1 minus 3x minus 2 times 2 plus 5x over negative 6. Which will give us 1 minus 3x minus 4 minus 10. Actually, I'll just make this simpler by doing this. Then now we have plus 1/3 times 2 plus 5x. That's our z, that's our y. So then now we can put it into this final equation. We got 2x plus 4 times 2 plus 5x over negative 6 plus 3 times 1 minus 3x plus 1/3 times 2 plus 5x equals 9. So by simplifying this equation, you'll get 2x 2/3, so plus 4 plus 10x over 3 plus 3 minus 9x. And this erases, so then we'll have plus 2 plus 5x equals 9. Okay, and then I'll erase these on the top because I need more workspace because this is a big equation. To erase those, we have 2x minus 9x is minus 7x plus 5x is minus 2x plus 10x over 3 is 4x over 3. 4x over 3. We have 4/3 plus 3, which is 13/3, plus 2, which is 16/3, equals 9. So 16 over 3 equals 9. Multiply by 3 on both sides, you'll get 4x plus 16 equals 27. Subtract 16. No, multiply by 3 on both sides, yeah. Okay. Wait, no, never mind. 4 over 3 plus 4 over 3 plus 3 is 13 over 3 plus 2 is 19 over 3. I did it wrong for a while. Okay, 19 over 3. 19 over 3. So then we subtract 19 on both sides, we get 8. Where x equals 8, and x equals 2. And that's our x. Now our y and our z's can be a lot cleaner. We're going to put the 2 in there. We'll get y equals 2 plus 5 times 2 over 6. 2 plus 5 times 2 is 12 over 6, which is 2. So y also equals 2. And then z equals 1 minus 6 plus 1/3 times 2 plus 5 times 2. 5 times 2 is 10 plus 2, 12. 12, so that's 1/3 of 12 is 4. 1 plus 4 minus 6 is -1. So z equals -1. And that's our solution set. 2, 2, -1. That was big work. But you have to do big work in order to solve a systems of equations. So our solution set is 2, 2, -1. I'll erase this. And then we'll we'll solve our next equation. Okay, so our best bet is to look for patterns into what we're doing. So for example, in this one, the best thing to do in math is to look for patterns. In this equation, there's a clear pattern. If you multiply this by 3, you get the same variables, right? For all 3. And you even get the same variable for the number. 6x plus 3y minus 3z equals 36. Since this and this is the same thing, and there's going to be a plane intersecting it. Okay, so I'm just gonna draw a makeshift 3D graph. I'm not a good 3D graph drawer. I'm just gonna draw a makeshift. There you go, right? If there's a plane, okay, let's say this is the plane, right? And then there's another plane, it's the same exact plane that's going over this plane. No matter what the third plane is, no matter the third plane's configuration, there will always be a line in which the third plane covers the second plane, and the line is infinite. The line is infinitely to the left, infinitely to the right. It's a line. It's going to be infinite. Therefore, this equation has infinitely many solutions. Or all real, well, no, not all real numbers. Infinitely many solutions. Simple. That was a simple question with a simple answer. So let's use it to our advantage. Okay, first of all, 34. What are the measures of angles A, B, and C? So we know that they all equal to 180, so we can write that now. A plus 5A minus C plus A plus B is equal to 180 degrees. Right? It's simple enough, right? We can add all of these together. We'll get 7A plus B minus C is equal to 180 and 80 degrees. And that's the only equation that we have. 7a plus b minus c equals 180. That's literally the only equation we have. There's no other way to make an equation that's different, that will yield a different result than 7a plus b minus c equals 180. If you say a plus 5a minus c equals 180 minus a plus b, that's the exact same thing as 7a plus b minus c equals 180. So we can plug in values that will satisfy this, that will satisfy this equation. So for example, if we want a to be 20, let's be realistic. If we want a to be 20 degrees plus, let's say c will be 20 as well, and then b, let's say b is 20 as well. Okay, that does not work. that doesn't work. Let's say b is 60. Okay, because 60 fits in here. 60 fits into here. That's equal to 180. And is it plausible? Okay, a 20, so that's 20 degrees, right? 20 degrees. B 20. C a is 20, so that's 100 minus 20, that's 80 degrees. And then 20 plus 60 is 80 degrees. Now it doesn't look good, but it's really plausible. It would be more like a that equation. Okay, let's assume a plus b. Let's assume a plus b is a right angle equation. So a plus b equals 90. Let's assume a plus b equals 90. Okay, so if a plus b is equal to 90, we have a plus 5a minus c is equal to 90. And that's basically our three equations. A plus 5a minus c. So we have 7a plus b minus c. 7a plus b minus c is equal to 90, equal to 180. A plus b is equal to 90. A plus 5a plus c is equal to 90. A plus 5a minus c. So if a plus b is equal to 90, then we can have we can subtract 7a, and subtract b. No. Let's add c, because I don't want to be dealing with so many subtractions. Okay, add c, both sides. B equals 180 minus 7a plus c. So then we can have a plus 180 minus 7b, minus 7a plus c is equal to 90. If we subtract 180 on both sides, well, minus 6a plus c is equal to 90. Is equal to negative 90. And then we can have 6a minus c is equal to 90. And that's the exact same thing as this equation. 6a minus c is equal to 90. So this equation has infinitely many solutions. And I just showed you one of the solutions. Okay. Next question. 41 is critical thinking. And I don't think critically most of the time. Find the values a, b, and c such that a linear system only has one solution. It only has negative 1, 2, and 3 as the only solution. Now, this is one of their solutions, so we can plug that in to the equation. Negative 1 plus 2 times 2 minus 3 times negative 3 is equal to a negative 1 minus 2 plus negative 3 is equal to b, and 2 times negative 1 plus 3 times 2 minus 2 times negative 3 is equal to c. So what's negative 1 plus 4 minus plus 9? Negative 1 plus 4 plus 9 is 12. So a is equal to 12. Negative 1 is 1, minus 2 is minus 2, minus 3 is minus 3. So b equals negative 4. And then 2 times negative 1 is negative 2 plus 6 plus 6. So c is equal to 10. Easy, we're done. A is 12, b is negative 4, and C is 10. That's the answer. And that's gonna be it for today's episode. If you liked it, if you liked this tricky question, it took me quite a while to think about that question. But if you like that tricky question, press the like button. Tell everyone if you want to pass a test. If you're using this book, Big Ideas Math Integrated 3, and you want to pass a test, you can look at these. If you're using any book, there's a CME integrated project or integrated math from Holt. You can or like from Pearson or something. You can also use this theorem because you can also use a series because it's the exact same curriculum. So if you liked it, press the like button, share it to everyone that you think would like it to pass a test, and see you next.